Okay, are the answers for the bell work, what you should have gotten on that. One thing to note here is on number 2, the inscribed angle. They gave you this 226, but that did not go with this angle. It went with the other one, the larger angle over there. So we subtracted 226 from 360 to get 134, and then plugged that into our inscribed angle formula. All right, so today we are looking at circle segment theorems. So one thing to really pay attention to, like this unit has a lot of information and it starts getting tricky on picking out what you're doing. So something to note with noticing the difference between segments and angles like we have been doing is you will notice on today's questions there are no degree signs. Arcs and angles use degrees. Segments is just a measurement, so it shows like how long that segment is. Okay, so we're looking at 4 types and they're all named by their segment or line type. Tangent. So this, and you notice it's 2 because there are 2 lines on this circle. So tangent, that is a tangent line because it touches 1 time. And then this other line or segment also touches 1 time here. So that makes it tangent. Okay, 2 tangent segments are equal or congruent. So the formula is tangent equals tangent. So in this case, I would say segment AB is equal to CB. So in a minute, when we start having expressions and things, so maybe it's, 5x plus 1 equals 2x, and you would solve that way. All right, secant. All right, this is going to be a secant line touches the circle twice, or secant segment, whichever. So like this one touches here and here. Okay. One thing you really have to keep in mind here is to find the whole. So you'll notice the formula has whole in it. You have to add both parts of the segment. So like for this first one, the outside is A, and then times I have to add, so the whole will be this. So I have to I accidentally flipped pages there. I have to be sure I include A and B. So I do A plus B. All right, and then for the other line, C is my outside part, and my whole would be C plus D. Then it's important to make sure you distribute those to solve. Okay, chord. So a chord is going to have endpoints on the circle like this. So you'll notice that it doesn't extend past the circle or through outside the circle like a secant did here. Okay, so it stays fully within the circle. And it's part times part equals part times part. Let me actually change that. Let's put parentheses because that confused some kids earlier. So for this, we have 2, so let's erase this off. It's 4, we'll start with this one with the A and B. So one part is A, the other part is B. That is going to get to be where it's an expression. So 3 times 2x minus 1. You have to make sure you have those parentheses. All right, my other chord, I can do D or C. Doesn't really matter here, but if I do D times the other part is C. All right, the only one that is not the 2 of the same type of lines is secant tangent. So you have to make sure that the left side of your formula is your secant. So that is the one that touches the circle twice because it has an outside and a whole. So that's here. So B is my outside. And then my whole would be B plus C. And that's just for this example. So like I said, maybe in a minute, one is 6 and one is 2. So 6 times 6 plus 2, or etc. Okay, so sorry, this side was the secant because it touches twice. And then this segment is the tangent. So you'll notice the tangent only has one part. It's not split up, so I just have to do a squared. All right, so this first one here, the segment theorem. So which of those four that we just talked about is this? So this one is chord, which is part times part equals part times part. So it doesn't matter which I put first here. I'm going to do, we'll do this one. So 14 times 15 equals, and then this one, x times 10. All right, and then you want to simplify. Okay, so 14 times 15 is 210. And then I would write x times 10 is just 10x. Okay, divide by 10. So x equals 21. All right, number 2 is, so this line touches twice, and so does this one. So that is secant. So then your equation is outside times whole. So 10 is my outside. And then remember that the whole is these added together. So 10 plus 42. Okay, and then my other secant segment, the outside is 13. Don't just put times x, remember? You gotta do 13 plus x. All right, so those parentheses were important so that we can then distribute. If you just have like this one, you can add these first. Okay, so now we have 10 plus 42 is 52, times 10 is 520. You can also type just the whole thing in your calculator, and it will work since there's no x's in it. Now this side I'm going to have to distribute, so don't forget to do both of them. So 13 times 13 is 169. 13 times x would be 13x. All right, subtract 169. Is 351, which equals 13x. Divide by 13. X equals 27. All right, and then they want NL. So I plug x in and at the NM location. So x is now 27. But since they want NL, that's the whole thing. So I have to do 27 plus 13 to give me 40. Okay, so on this second page, I want you to take, let's do 1 minute. Be super fast. And fill in what each of the segment theorems are. Okay, so like, is it chord, secant, etc. Take 2 minutes, then I'll check back. All right, so let's check our answers here. So number 3. Lydia, what'd you get on 3? Tangent. Okay. David, what'd you get on 4?
I thought we were supposed to do 3.
Nope. Brendan, what'd you get
hold on.
Okay.
Secant tangent.
Yes.
I thought we were supposed to do 3.
Number 5, McKenna. Nolan, 6. Grace, 7. Good. Caden, did you get 8? What'd you get? Good. Okay, so like I said, that should give you your starting point. If you can pick those out, then you just kind of can plug into the formula. And I'll try to show you like the main mistakes I do see. But all right, so on 3, if they're both tangent, it doesn't matter which side we plug the line into. So the formula is tangent equals tangent. Okay, so raise your hand if you can write the equation. David?
5x plus 23 equals 8x minus 19.
Yes. Could we have flipped that on this one?
Yeah.
Yes. If it gets to the secant tangent one, we can't because they're not the same type of line. Okay? All right, now we solve. So minus 5x, add 19. I meant to finish that off. Okay, what did we get for x? 14. Good. And just a quick reminder, quiz or test, you'll get like a point here, point here, point here. Okay? So try to be careful there. So if x is 14, they wanted CB, so I need to plug in here. So Blaze, what you got? 93. So CB equals 93. Everyone agree? Get the same? Good. All right, so 4 is a secant tangent. So this one's a little bit tougher. What is the formula? Remember, I want the secant one on the left, tangent on the right. So what's the formula? McKenna, what's the formula?
Outside.
Mm-hmm.
Outside squares.
Good. All right, I want you to, so this one's the secant, okay? Label this because I see this mistake fairly commonly. The one that only touches once is the tangent. It has to go like that. Like the secant has to be the outside times the whole. The tangent has to be the one that's squared, okay? So then let's plug in. I think of that, by the way, as like secant has 2 parts. Tangent only has the one, okay? That might help you. Okay, so the outside on the secant line is what? Which number? 9. How do I find the whole? 9 plus 16. If you want to do that in your head first, that's fine. It won't always be just regular numbers, but okay, now the tangent, I only have outside because that's a tangent is only outside. So what am I going to be squaring? 3x. And you do want to put that like in parentheses here because you're going to square all parts of it. Okay, so let's simplify. So 9 plus 16 should give us 25. And that's what's 9 times 25? Okay, now be careful here. You got to think back to algebra a little bit. This squared applies to both. So if I square 3, what do I get? And then the x is squared as well. Okay, what would I do next? Not yet. How do I move that 9? Divide it. So we're kind of going backwards here, aren't we? But so 225 divided by 9 is what? Bless you. 25. Now, what's the opposite of squared? How do I get rid of that? Square root. So x equals the square root of 25. 5. And kind of try to do a visual check. Like if you got 25, like if you'd stop there, that would mean that this bottom segment is 75. Does that look like it is that much bigger than the 9? So kind of try to look at it like that. So if x is 5, they didn't ask for it here, but if they did, what would this segment be? 15. Does that look more reasonable to the 9 rather than 75? Maybe? I think 75 looked like it'd be real big. Okay, let's try 5. I plugged 5 into 3. Yeah. It didn't ask for that one. I was just saying if it did, then you just plug it in. Okay, number 5 is secant, secant. So actually, let's just take 1 minute, or like 30 seconds. Write all of your formulas for 5 through 8 before you plug in, or if you want to try to plug in, if you're feeling good, go ahead. But write the formula, then go back and plug in. Okay, so make sure checking your equation here on 5. I know a couple of you did solve, and that's okay. So if it's secant, secant, that's outside times whole equals same thing because they're both secant lines. So the outside doesn't matter if I start with the 8 or 9. Okay, so if I did the 8, what would the whole be inside? 8 plus 19. Okay, for the other one then, the outside is 9. What would I put for the whole? What's the whole there? Is it x? No? 9 plus x. If you did x plus 9, that's the same, okay? Just order won't matter there. Question?
I did opposite.
The other way, that's fine. Yeah.
9 was first.
First, that's fine. Yeah, you can flip these because these are both the same. Okay? All right, now I would probably add this one before I distributed, but it doesn't matter. So if it's 27 times 8, what would that give us? Was it? 216? Okay. Now this one you do have to actually distribute. So 9 times 9 is 81. 9 times x is 9x. Okay, next I would subtract 81, divide by 9. So I got 135 equals 9x. Divide by 9, x equals 15. Do you guys get that? I think most of you are done with that one, so I kind of went through that one quick. Okay, 6 is chord, chord. All right, I'm going to call on people to write the equation parts. So, chord, chord. Brenna, what's the formula for chord, chord?
I don't know.
A plus, or A times B equals
Okay. I'm going to write part times part for this part because it'll look a little different on this one, right? So what should I plug in? So if I'm going to do this side first, what am I going to be multiplying? 6 times 6 equals, what am I going to have for the other side? Corbin, what's the other side going to be? Yes. Okay. Everyone look here, please. I saw this a lot. 4 times, don't write this right now. That is only multiplying 4 by the 5x. How do I make that 4 multiplied by everything? Parentheses. That's very important because you do have to distribute it. All right, so 6 times 6 is 36. Kyle, what's that right side going to distribute to?
20x minus 4.
Good. Okay, add 4, so that's 40 equals 20x. So what times 20 equals 40? 2. All right, now it wants dB. So what should I do first? Plug 2 in for x, so that's 5 times 2 minus 1. So what's that give us? 9. Is that my answer? No. Add the 4, because it is wanting like the whole. So 9 plus 4 gives us dB to equal 13. Okay. Tangent, tangent. All right, if I plug that in, Alexis, what would our equation be?
23 minus 2x equals 12x plus 1.
If someone wrote the 12x plus 1 first, is that okay? And flipped it. Is that okay? Yes. Okay, I would probably start with adding the 2x just to keep your x positive. So I have 14x. What do I need to do with the 1? Subtract it from 43. So 42 equals 14x. Divide, what does x equal? 3. Okay, and it wants wy specifically. So we got to plug into this one. So type that in your calculator. 43 minus 2 times 3. Be careful about where you put the x. I saw we had one like that and people wanted to put it with the 43 because x is usually first, but it's switched here. All right, Alex, what'd you get? 37. Questions there on that one? Okay, the hardest one for last. It's not hard, it's just that this can be, you have to put them in the right spot. Which line, so pick 2 letters, which line is my secant line? PN, okay? So the formula is outside times what? Whole equals outside squared. So remember, this side has to be the secant, so let's plug that in now. What's the outside number? 8. What do I put on this one, on the whole? A lot of people had it right, so what was it?
8 + 5x - 1.
Yes. So it's a little bigger. You're just going to have to combine some like terms before you distribute, okay? Equals. All right, this one is your tangent. A lot of you wanted to add an x on that 16 because our first one had an x. It doesn't always have an x, just if it's there, yes, if not, no. So what am I going to square in this case? 16. Okay, so let's simplify. So this is going to be 8 times 5x plus what? 7, good, equals 16 squared. 256. Okay. Now what would I do? Distribute. So make sure you combine those like terms first. 8 times 5 is 40x. 8 times 7, 56. Okay, so I know I'm going to take that 56 out, which is going to come to a nice, pretty 200. Divide by 40. What does x equal? I don't know if you guys did this in elementary. We would like mark off the zeros. Now I just have 20 divided by 4, which is what? Okay, and then it wants NP. So plug in, right? So 5 times 5 minus 1 will give us 24. Is that all at once, or should I add on? What? Yes, it just wants this. So I don't add on this one. So just be careful if this is like, do they want the whole, do they want the part? All right, the last two here are kind of like a puzzle. It's a lot easier than it looks. Okay, so pause for a second, look up here before you start freaking out. All of these, think of this as like 3 separate sections, okay? So I'm just going to look here first. If I didn't have any of this going on, ignore that right now, okay? What would just these two be? Which of those 4 we learned? What? Tangent, tangent. And tangent is what to the other line? Equal. So if this is 11, what is this? 11. Are these all 3 tangent, tangent? Yes. So if this is 16, what's this one? Okay. And this one's 9.5. So is this one, right? Okay, but what does it want? Or here, let's go ahead and write tangent. Tangent was our segment theorem. What does it want here? Perimeter. So that is, what is perimeter? It wants it of the triangle. So it wants all of this. So what would I do? Add them all up. I should be adding all of, all the ones around here. It's not, oh, my thing's frozen. But another thing you can do is times the small ones by like 11 times 2, 16 times 2, 9.5 times 2. Add them. You can add all of them, then times by 2. There's a few options. So add all of these. Once you add them, just check with your neighbor, please, because it is easy to make a little calculating mistake. Add them and check. Okay, so just an option. I like to do this. If you want to just add them all, it's totally fine. I like to do 16 times 2 is 32. 11 times 2 is 22. 9.5 times 2 is 19, and add those. It's totally up to you. That's just what I like to do. Okay, so what should that come out to? 73. All right, questions on that one? Because the next one's the same, just has some X's. Okay, so let's take a minute. We are looking for a quadrilateral, but that's the same in terms of perimeter. What do we already know? Like, this is 9. What's this one below it? 9. So it's still tangent, tangent going on. A little more complex, though. I don't think we have anything else right now. I can start, though. Do you have any two parts that are equal? What? Well, we got the 9 already. So think solve for x here. Like, because the one up at the top is y. So this here, if I was going to solve this, what's the equation? Are they equal? All right, so what's the equation? Yeah, so we're just breaking this into parts, okay? So subtract x from a 5x would be 4x. Add 8 is 12. Divide by 4. What's x equal? 3. Okay, so I have that. Which one should I plug into here? X plus 4 or 5x minus 8? Does it matter? Why? Why does it not matter? They're equal, so I'd probably do x plus 4 because I can add 3 and 4 in my head, right? So 3 plus 4 is 7. If I plugged into this one, is 15 minus 8 7? Yes, but okay. I can't do anything over here yet because there is nothing there. Oops. So what do I need to do next then? What? To get the y. Do I have the two congruent or equal parts for y? Like if I start with y plus 2. Do I have its equal? What? Do I have from here to here? Yes, so 3y minus 10. That 13 is what we're going to use last here. Okay, so minus y is 2y. Add 10 is 12. Divide by 2. Y equals 6. So I can fill that in. And I need to plug in. Does it matter which one I plug into? No, so I would probably plug into this one, but up to you. So what's that little segment equal over there? 8. If you plug into the other, it's 18 minus 10, which is still 8. Okay. Now I got to think back a little bit here. I think we did this in like the first unit. If this whole side is 13, we have from here to here is 8. So what does this have to be? Or how can we find that? 13 minus 8, which is what? 5. Okay, so I'm adding all of these so far. I like to circle all the ones, by the way, because a lot of times at the end I'll see kids like left off one circle and then they left that out of their addition. So what do I still need? I still need one side that I haven't written. What? This one, which will be 5. So if you want to think like, okay, then I need 8 numbers there that I should be adding. Again, if you want to double the sides first, so 8 times 2 is 16, 9 times 2 is 18, 7 times 2 is 14, 5 times 2 is 10. And just add those 4, up to you. So take a minute, finish that off, and raise your hand when you are done. Okay, so just to check in here, you should have added those and gotten 58. If you are virtual, make sure you are submitting the homework for today, 6.4 homework and homework check. We will have a quiz next class, so if you do not have 6.3 and 6.4 done, I would try to get that done as soon as possible because that's what that will be over. And then we'll have 2 more lessons before the test. All right, have a good day.